Good morning. In previous class, we have studied De Moivre's theorem and its applications. Today, let us continue the problems of applications of De Moivre's theorem. Okay, let us start with the question. Second question, find the value of 4 plus 3 into square root of minus 20 the whole raised to half plus 4 minus 3 into square root of minus 20 the whole raised to half. Option 6, B 0, C plus or minus root 5 and D plus or minus 3. Okay. Question. Find the value of 4 plus 3 into square root of minus 20 the whole raised to half plus 4 minus 3 into square root of minus 20 the whole raised to half. Options A plus or minus 6, B 0, C plus or minus root 5 and D plus or minus 3. Okay, here we are given an expression and we have to find the value of that. But first of all, how we can identify the origin of this question? That is, from which chapter this question belongs. Now we know that this question belongs to complex numbers. But in your exams, among all other questions, how we can identify that this chapter belongs to the complex numbers? Here, this expression does not contain the imaginary form or the imaginary number I or any preliminary any identity of a complex number. Then how we can confirm that this question belongs to the complex number? Okay, this is the hint for that. That is, this portion is the square root of a negative number, means an imaginary number. Okay, so this is the hint to confirm that this question belongs to the chapter complex numbers. Okay, so we can start with the question. Here we have to find the value of the whole expression. First of all, we take only this expression and find the value of that. Then this portion is the conjugate of this expression. So we can easily find the value of this expression. And then we take the sum of the two expressions. That is the procedure. Okay, so we start with the question. First of all, take only this expression. That is 4 plus 3 into square root of minus 20 the whole raised to half. Okay. First of all, we have to bring this expression into the standard form. Any math student can easily have an idea that to bring an expression including square root, just take the square of that expression, isn't it? So, first of all, take the square of this expression. That is 4 plus 3 into square root of minus 20. Okay. Good morning. In previous class, we have studied De Moivre's theorem and its applications. Today, let us continue the problems of applications of De Moivre's theorem. Okay, let us start with the question. Question number 2. Find the value of 4 plus 3 into square 20 the whole raised to half plus minus 3 into square root of minus 20 the whole raised to half. Options A plus or minus 6, B 0, C plus or minus root 5 and D plus or minus 3. Question. Find the value of 4 plus 3 into square root of minus 20 the whole raised to half plus 4 minus 3 into square root of minus 20 the whole raised to half. Options A plus or minus 6, B 0, C plus or minus root 5 and D plus or minus 3. Okay, here we are given an expression and we have to find the value of that. But first of all, how we can identify the origin of this expression, or from which chapter this question belongs. Now we know that this question belongs to the chapter complex numbers, since we are discussing the problems of complex numbers. But in your exam, among all other questions, how we can identify the origin of this question? Okay, this expression is not in the standard form a plus ib, or it does not contain the imaginary number I, or preliminary any evidence to confirm that this expression belongs to the chapter complex numbers. Okay, first of all, we take this portion. Here, this expression contains the square root of a negative number. That is the hint to confirm that this expression belongs to the chapter complex numbers. Okay, so let us start with the question. Here, first of all, we take only this portion and find the value of that, and then this portion is the conjugate of this, and we can easily find the value of this portion. Okay, then take the sum of two portions. That is the procedure. Okay, then let us start with the question. Here we have to find the value of this whole expression. For that, first of all, we take only this expression and find the value of that. And since this expression is the conjugate of this, we can easily find the value of that and then take the sum. That is the procedure. Okay, then we start with only this expression. First of all, put this expression as x plus iy. That is, put 4 plus 3 into square root of minus 20 the whole raised to half as x plus iy. Okay, then first of all, we find the value of this expression. That is, we know that this that is 4 plus 3 into square root of this portion becomes minus 1 into 4 into 5. That is, square root of minus 20 can be written as minus 1 into 4 into 5. Okay, that is, this becomes 4 plus 3 into, we know that square root of minus 1 is I and square root of 4 is 2. So that becomes okay, that is 4 plus 6I into root 5. Is x plus iy. Okay. Here we have to find the value of this whole expression. For that, first of all, we find the value of only this expression, and since this expression is the conjugate of this expression, we can easily find the value of this expression from the value of this. Okay, that is the procedure. For that, first of all, we take this expression arbitrarily as x plus iy. That is, put 4 plus 3 into square root of minus 20 the whole raised to half is equal to x plus iy. Arbitrarily take this expression as x plus iy. First of all, we find the value of only this expression. That is, we know that here we know that minus 20 can be written as minus 1 into 4 into 5. That is 4 plus 3 into minus 1 into 4 into 5. And we know that the square root of minus 1 is I and square root of 4 is 2. So that becomes 4 plus 6I into root 5. That is, minus 20 can be written as minus 1 into 4 into 5. That is, square root of minus 1 of 4 is 2. So that becomes 4 plus 6I into root 5. Okay. Here, the value of the square root of this expression is x plus iy. That is 4 plus 6I root 5, the whole raised to half is x plus iy. Okay, this expression is equal to this expression. That is 4 plus 3 into square root of minus 20 is 4 plus 6I into root 5. So, the square root of this expression is x plus iy. Next, we bring this expression into the standard form. Every math student have a clear idea that in order to bring an expression including square root into standard form is to just take the square on both sides. Okay, so we can square LHS, we can take the square on LHS and RHS. So first of all, we just take the square on both sides. So taking the square on LHS, it becomes 4 plus 6i into root 5. That is, the square of square root of a number is that number itself. Okay. Then take the square on RHS. That is x plus I by the whole square. That is x square plus I square y square plus 2i into xy. And we know that the value of I square is minus 1, so that becomes x square minus y square plus 2i into xy. Okay. So we get this complex number is equal to this one. Okay. We know that when two complex numbers are equal, we can say that its real parts are equal. Similarly, its imaginary parts are equal. So we can equate the real parts and imaginary parts of these two expressions. Okay. Now we equate the real and imaginary parts of these two equations. That is, real part of LHS is 4 and RHS is x square minus y square. Similarly, imaginary part of LHS is 6 into root 5 and RHS is 2xy. Now we can equate them. That is x square minus y square is equal to 4 and 2xy is equal to 6 into root 5. Okay. From these two equations, we find out the value of x square plus y square, and then using the values of x square minus y square and x square plus y square, we find out the value of x and y. That is the procedure. Okay, now we know the identity, that is a plus b whole square is equal to a minus b whole square plus 4ab. From this we get a plus b is equal to square root of a minus b whole square plus 4ab. Now, using this identity, we find out the value of x square plus y square using the values of x square minus y square and 4x square y square. Okay. Then we substitute for a for x square and b for y square. Then we get the value of x square plus y square from x square minus y square. That is, substitute a for x square and b for y square. Then this becomes x square plus y square is equal to square root of x square minus y square the whole square plus 4x square y square. Okay. Using the identity a plus b whole square is equal to a minus b whole square plus 4ab, we get this identity, that is a plus b is equal to square root of a minus b whole square plus 4ab. Now, substituting for a for x square and b for y square, this relation becomes x square plus y square is equal to square root of a for x square and b for y square, that is square root of x square minus y square the whole square plus 4x square y square. Now we have the value of x square minus y square, and just taking the square on this equation we get the value of 4x square y square. Okay, that is just take the square on this equation, we get 4x square y square is equal to 36 into 5, that is 180. Now we get x square plus y square is equal to square root of x square minus y square the whole square, that is 4 square 16 plus 4x square y square, that is 180. That is square root of 196, which is equal to 40. Okay. Now we have the values of x square minus y square and x square plus y square. Just name the equations: x square minus y square, equation number 1, and x square plus y square is equal to 40, equation number 2. Then using these two equations, that is x square minus y square and x square plus y square, we find out the values of x and y. Okay. Now we know, just taking the sum of these two equations, that is adding equation number 1 and 2, we get 2x square is equal to 18. That is x square is equal to 9 and x equal to plus or minus 3. Similarly, to find out the value of y, just take the difference of these two equations. Then we get, for convenience, we take the difference of second equation minus first equation. Then we get 2y square is equal to 14 minus 4, that is 10. 2y square is equal to 10, that is y square is equal to 5, and then y is equal to plus or minus root 5. Okay, now we have the values of x and y. Now we just substitute the expression. We have to find out the value of x plus iy. From on that equation, we just substitute these values. Now we get the values of x and y, that is x equal to plus or minus 3 and y is equal to plus or minus root 5. Now we have to find the value of this expression, that is 4 plus 3 into square root of minus 20 the whole raised to half plus 4 minus 3 into square root of minus 20 the whole raised to half. We have arbitrarily taken the value of 4 plus 3 into square root of minus 20 the whole raised to half as x plus iy, and this expression is the conjugate of this, so that is x minus iy. So we have to find the value of x plus iy plus x minus iy, that is 2x. Okay, that is the value of this whole expression is 2x. If x takes the value plus 3, this becomes 6, that is positive 6, and if x takes the value negative 3, this becomes minus 6. Okay, so the whole value of this expression is plus